But there is some information that's missing from our step graph, and this is why I'm going to now return back to this slot over here. Okay? Yeah, Jitsu.
Just a question. If you park for 1 hour, do you pay $11 or $22?
What a great question. If I park and I'm driving, well, actually, I'm not driving out. You have to you pay before you actually get to the final thing, right? And it's literally like the clock ticks 60 minutes, right? The machine, or rather the car park, has a choice, right? Which one is it going to charge you, do you think?
22.
I think I can safely put money on the fact that they're going to charge me 22 and not 11 because, why wouldn't they charge you $22? Not to mention the fact that if you pay and then you're going to have to take a minute to walk to your thing, you're pretty much
you
it,
get
right?
15 minutes.
Yeah,
Okay, you'll be given some kind of little window there, right? Now, being that I've got this hollow circle, we've met these before in drawing like number lines and inequalities and that kind of thing. I've got a filled circle up here. That means that I've got a hollow circle, an open circle down here. These points coincide. They are directly, and now I will put in, they are directly above one another. So, is this a function or is it a relation?
It's a function.
It's a function because for every single time you'll get one and only one cost out of it. Right? So I could stick the vertical line test through this and it'll work. And I can keep on going. The steps go up like so.
So with functions, there can be lots of x values to the same y value. But
Lots of x values to the same y value. Yes, because I've got lots of times within here, for instance, 5 minutes, 10 minutes, 15, and they're all mapping towards that same y value. So that's exactly right. So what we're thinking of here, the fancy terms for this are the independent variable and the dependent variable, right? So it's like you feed in a time and it'll give you a cost, okay? So we're going from this way to that. And yes, you can have multiple values that way. So I'll just finish off. You can see there's that higher step there to get up to $60. And then another higher step again. And then what happens here? What should I put here?
an arrow.
I should put an arrow because it just keeps going indefinitely, unless they tow your car away, I guess. Now, one last little thing, and I'll agree that this is kind of open to interpretation. What happens here? I have an endpoint, but I haven't said what happens there. What do you reckon?
Close.
Close.
Closed or filled? Now, I'll say this is open to interpretation. Just as a personal thing, I would probably say open. The reason why is because, what does that point actually represent? You've been in there. Now, don't forget, right? I know this is this is why it's open to interpretation. This is a physical, actual thing. And now when we cross over to here, this becomes a bit more abstract, right? What does this axis represent?
0 minutes.
This axis represents 0. Not I just got in. That's an actual time. That'd be 0.000001, whatever. What this really means is 0 minutes. I would say you haven't entered the car park
How
yet,
about seconds?
right? Well, yeah, 0 hours is also 0. If it's really 0, right? If there's no rounding or anything like that. Now, I'll just say, like I said, you could open to this to interpretation. You could fill that in if you interpret 0 as I've just entered. But I would probably say, if you've just entered, then some time has elapsed, right? Anyhow, I'm going to draw mine like that. Some time has elapsed, right? Okay, now, this is a step graph, okay? A step graph is a very... Sorry?
Is that the title?
No. Here comes the title. A step graph is a particular kind of a general type of graph where, I've got all of these holes in here. I've got all these holes. These things have technical names. They're called discontinuities. Discontinuities. Okay? Discontinuities because it's not continuous. There's a break in there. Okay? More specifically, these particular discontinuities, they're called jump discontinuities because you jump directly from one value to another. There's no smooth change from 11 to 22. You just jump straight away up to the next value. So this idea of a graph that has a bunch of discontinuities, right? Clearly there's a bunch of different equations that corresponds to each of these, right? If I had a look at this, what would be the equation? Keeping in mind I don't have an x and y axis, I have a t and c axis, what would the equation of this portion of the graph be? C equals 11, and then it'd be C equals 22, and C equals 33. But this whole thing describes one situation, right? It's all one situation. It's all one function, right? It is a function, not a relation. So therefore, this is the step graph is generally speaking what we call I'll put it over here, a piecemeal function. Piecemeal is a very old-fashioned word. It comes from, it does sound like oatmeal. It comes from like piecework, like you get like bits and pieces, different separate sections of something. And these are the pieces that make up this function. These are also, the technical name is a piece, am I spelling it right? I before E. It looks funny if I spelled it wrong.
Except
Oh,
after.
it's pies. Like
It looks so weird.
But it's
I before
P-I-E.
E except after
It's
I.
pie.
No,
Yeah,
that's
yeah.
weird.
I spelled it right the first time.
I hate
Okay.
spelling.
The technical
Oh my
name
God,
for this,
stop. No, it's I before E except in case of C.
but that's
After
full
C.
of it's full
Yeah,
of
that's
exceptions,
horrible.
right?
Yes.
No, it's pie and then
Yes, yes, we got it.
Pie and then
Pie wise.
Piecemeal.
pies.
Piecemeal is what you can call these, and no one will have any ambiguity. But the technical phrase for these, just like discontinuities, the technical phrase for this is a piecewise defined function. Because what is the equation here, right? It's going to be C is equal to, and it's equal to different things at different times. So what I do is I put in a curly brace, right? And I say, well, okay, C is equal to 11 for a certain restricted domain. What domain? At least on my graph, what domain?
Less than 1.
0. Now, let's be really specific, right? Because I've got these boundaries here, right? I've got less than, and then T, and then 1, right? And not inclusive, right? Then I change into 22. When do I change into 22? At 1, and I include that, and then T, and then I don't include 2. And I can keep going, right? 33, 44. I'm so close, I might as well finish. 60. And then 77 for, on my graph at least.
Greater than or equal to 1.
Yeah, from 5 it just goes, doesn't it? It just goes. T is greater than or equal to 5. Okay, so you can see that what I have is these are the actual parts, and these are where those parts are true, where the pieces apply. Does that make sense?